To begin, we are told that ABCD is a rectangle. So let's place this 90-degree symbol here to remind us of this. Our next step should be to eliminate the information highlighted. This information is unnecessary for solving the question. It is meant to act solely as a distractor. Now, we are comparing the area of a triangle to the area of a rectangle. The formula for the area of a triangle is as follows. And to find the area of a rectangle, we need this formula. Notice that both formulas include both base and height. Also notice that our triangle and our rectangle both share the same base. The height of the triangle is shown here, and we'll call it h. And this height is the same height of our rectangle. So now let's do our calculations. The area of our triangle will be equal to 1/2 times b times h. And the area of our rectangle will be b times h. Notice that the area of the triangle is half the area of the rectangle, so our ratio will be 1:2. The answer is...
Okay, so this is a very interesting one. We want the area of the triangle to be an integer. Well, of course, any number, any integer, times 126 would be another integer, but it's at 0.3 or 3/10, that's the issue. That has to be multiplied by either 10 or a multiple of 10. So, first of all, things that are not multiples of 10 we can eliminate right away, but here's the really tricky part. We're going to multiply it by h, but the formula, of course, for the area of a triangle is 1/2 base times height. So we're going to multiply it by h, but we're also going to multiply it by 1/2. So 1/2 times h has to be a multiple of 10. Well, 30 times 1/2 is 15. That's not a multiple of 10. 40 times 1/2, that works. 50 times 1/2 is 25, not a multiple of 10. 80 times 1/2 is 40, that works. 100 times 1/2 is 50, that works. 150 times 1/2 is 75, not a multiple of 10, that doesn't work. So the only ones that work are B, E, and F, the multiples of 20. We have an irregular pentagon with 3 right angles, and we want the area. Now, one way to approach this would be to subdivide this into a bunch of different little triangles and right angles and add up all the pieces. But it's actually easier to think about the negative space, because if we just add this little bit right here, then we get a full square. So the square is 10 times 10, so the square has an area of 100. Well, what's this little area here? Well, this length is 10, this length is 6, so this is 4. Top is 10, bottom is 7, so this is 3. This is a 3, 4, 5 triangle. The area of a 3, 4, 5 triangle, 1/2 base times height, 1/2 3 times 4, that's 6. And so we start with a square with an area of 100, and we subtract 6. And so the area of this figure is 94. And that is the answer, 94.
All right, to begin, please recognize that since this triangle has 2 sides of equal length, these 2 angles must be equal. Now, since all 3 angles in this triangle must add to be 180 degrees, we can conclude that these 2 angles are 65 degrees each. Now recognize that this angle is the smallest of our 3 angles. So as such, the side opposite that angle must be the shortest length. Now the other 2 sides have length 8, which means side AB must have a length less than 8. So we now know that column A is a number less than 8, in which case column B is greater than column A, and our answer is B. To find the area of the shaded region, we're going to find the area of the large triangle and then subtract the area of the small triangle. So let's begin. First, notice that the large triangle is a right triangle. Also notice that the hypotenuse is twice as long as the base. This tells us that the large triangle is a 30, 60, 90 triangle. So we can now add our 2 angles here. We can also conclude that the third side of the large triangle has length √3 times x. Similarly, since the small triangle is also a 30, 60, 90 triangle, we know that the length of this side is root 3 times y. We're now ready to calculate our areas. We'll begin with a large triangle. To find the area of the large triangle, we'll multiply the base times the height and then divide by 2. From this, we'll subtract the area of the small triangle. The area of the small triangle will be equal to the base times the height divided by 2. And now we can expand both numerators and then combine our fractions. And finally, we'll factor out a root 3 from the numerator to get the following. So as you can see, our answer is E.
In order to compare the area of the triangle with 16, we need to find out the area of the triangle. Now, if we can't, we are going to go ahead and say that the relationship cannot be determined from the information given. So let's see if we can find this area. Now, this triangle is a right triangle, and one of the other two angles is a 60 degrees. The angles in any triangle add up to 180 degrees, and that means that this angle out here is going to be 30 degrees. So this is a special type of a right triangle called a 30, 60, 90 triangle. And you must remember the relationship between the side lengths on a 30, 60, 90 triangle. Let's quickly review that relationship. Let's say we have a 30, 60, 90 triangle. This angle being 30 degrees and this angle being the 60 degrees. And here's the right angle. Now, if the hypotenuse is 2x units long, then the side opposite the 30 degrees, which is this side, is exactly half the hypotenuse, which is x units long. And the side opposite the 60 degrees is going to be x times square root 3 units long. This is the relationship that you need to remember for a 30, 60, 90 triangle. Now, in this triangle, it's given that the hypotenuse is 8. Therefore, we could say that 2x is equal to 8. 8 is 2x. So then what's x? X is 4. X is the side opposite the 30 degrees. Therefore, this length is going to be 4. And the side opposite the 60 degrees is x square root 3 or x times square root 3. So that's going to be 4 times square root 3. Now we know the base and the height of the triangle. So we can find its area. So the area is given as base times the height divided with 2. So that's 4 times 4 square root 3 over 2. And we can simplify this. So that becomes 2 times 4, which is 8 times square root 3. Now, square root of 3 is a number that's less than 2 because 2 square is 4. So this is going to be less than 8 multiplied with 2. And 8 multiplied with 2, 16, is what we have in column B. Therefore, column A is smaller. The quantity in column B is greater.
One approach here is to check each answer choice and see which value of x yields the measurements of a right triangle. We're going to examine the more algebraic approach. First, using our Pythagorean theorem, we can create the following equation. Now let's expand each of our squares. And now we'll simplify the terms on the left-hand side. Let's set this equation equal to 0. We'll do this by subtracting 4x squared from both sides, subtracting 28x from both sides, and subtracting 49 from both sides. Now notice that we can divide both sides by 6. And now we can factor this quadratic. When we do so, we get the following. From here we can conclude that x equals either 3 or negative 2. Since negative 2 will yield measurements with negative values, we can cross this out. So as you can see, our answer is B.